Hybrid energy systems are the future of sustainable power generation. They combine multiple energy sources, like wind, solar, and others, to provide reliable, efficient, and environmentally friendly electricity. This slide introduces the topic and highlights the key benefits of hybrid systems. Unparalleled efficiency by optimizing the use of different energy sources. Improved reliability through redundancy and complementary generation. Enhanced environmental responsibility by reducing reliance on fossil fuels. The image on the right shows a real-world example of a hybrid energy facility with both wind turbines and solar panels. Hybrid energy systems combine renewable sources like solar and wind with conventional sources like natural gas or diesel generators, as well as energy storage technologies. These integrated systems provide a more reliable, efficient, and sustainable power solution compared to relying on a single energy source. Hybrid systems are being deployed in a variety of settings, from remote off-grid communities to industrial facilities and residential applications. They offer a flexible and resilient energy solution that can adapt to varying energy demands and environmental conditions. Hybrid systems are designed to seamlessly integrate with existing power grids, enabling bidirectional energy flow and improving overall grid stability and reliability. Hybrid energy systems combine renewable and conventional energy sources to provide reliable, sustainable electricity. This integration of technologies like solar, wind, and fossil fuel generators helps mitigate the intermittency of renewables and reduce the carbon footprint. The key is an intelligent control system that manages the flow of energy, adjusting the contribution of each source to meet changing demand. This allows optimal performance and energy utilization across the entire hybrid system. By leveraging the strengths of different energy sources, hybrid systems can deliver a more reliable and environmentally friendly power supply. Hybrid energy systems combine renewable sources like solar and wind with traditional fossil fuels. This helps reduce greenhouse gas emissions by offsetting the use of polluting fossil fuels. Diversifying the energy mix also increases energy security by reducing reliance on any single fuel source. The declining costs of renewable tech can lead to long-term cost savings for consumers and businesses. Hybrid systems provide backup power when one source is unavailable, improving overall reliability and reducing the risk of blackouts. Hybrid energy systems are a crucial part of fighting climate change by reducing greenhouse gas emissions. These systems combine renewable sources like solar and wind with conventional generation, lowering the overall carbon footprint by up to 25%. Widespread adoption of hybrid systems could avoid over 1.2 million tons of CO2 emissions annually. The emissions reductions from hybrid energy result in billions of dollars in societal savings. This makes hybrid energy a key technology for a more sustainable future. Hybrid energy systems combine renewable and conventional energy sources, creating a more diverse and resilient power supply. Renewable sources like solar, wind, hydropower, and geothermal provide clean, sustainable energy, while conventional sources like natural gas, coal, and nuclear offer reliable baseload power. By diversifying the energy mix, hybrid systems reduce reliance on any single source, enhancing energy security and safeguarding against disruptions or shortages. This increased energy security is crucial for critical infrastructure, remote communities, and industries that require uninterrupted power, as it ensures continuous power generation. Hybrid systems leverage the strengths of different energy sources, providing a more reliable and resilient power supply to meet our growing energy needs. Hybrid energy systems can provide significant cost savings compared to conventional systems. Key areas of savings include reduced fuel costs. Hybrid systems use less fuel, saving $30,000 per year. Lower maintenance costs. Hybrid systems require less maintenance, saving $10,000 per year. Decreased electricity costs. Hybrid systems generate more of their own electricity, saving $15,000 per year. In total, the hybrid system can save over $50,000 annually compared to a conventional system. These substantial cost savings can translate to improved profitability and a more sustainable business model. Highlighting these financial benefits is a key advantage of hybrid energy systems that we should emphasize. Hybrid energy systems offer improved reliability compared to standalone renewable or conventional energy sources by integrating multiple energy generation and backup technologies. Hybrid systems can provide a more stable and consistent power supply. The redundancy built into hybrid systems helps ensure continuous electricity, even during disruptions or fluctuations in renewable energy production. Advanced control systems and monitoring capabilities enable real-time adjustments to optimize energy generation and distribution, further enhancing reliability and resilience. This increased reliability is especially important for critical infrastructure, industrial facilities, and remote communities that cannot afford power disruptions. Hybrid energy systems combine different types of power generation to provide reliable, sustainable electricity. Renewable sources like wind, solar, and hydroelectric generate clean, renewable power. Conventional sources like natural gas and diesel provide backup and supplemental power when needed. Energy storage technologies like batteries and flywheels help balance supply and demand. Power conversion and transmission equipment integrates the various energy sources and delivers electricity to the grid. Renewable energy sources are becoming increasingly important as we transition to a more sustainable energy future. Solar power uses photovoltaic panels to convert sunlight directly into electricity. These systems can be used for both small-scale residential applications and large-scale utility-grade solar farms. Wind power harnesses the kinetic energy of wind to generate clean, renewable electricity. Wind farms are often located in areas with consistent and strong wind patterns, such as coastal regions and open plains. Hydropower uses the gravitational force of flowing water to spin turbines and generate renewable electricity. Hydroelectric dams and run-of-river systems are mature and reliable technologies that can provide baseload power to the grid. Geothermal energy systems harness the natural heat from the Earth's interior to produce steam or hot water, which can then be used to generate renewable electricity or provide direct heating and cooling for buildings. Fossil fuels like coal, oil, and natural gas have been a dominant energy source globally, providing reliable and abundant power. However, their environmental impact and finite nature have driven the need for cleaner alternatives. Nuclear energy offers a carbon-free baseload power source, but concerns around radioactive waste and safety have limited its widespread adoption. Hydroelectric power harnesses the energy of flowing water to generate electricity without direct greenhouse gas emissions. Large-scale hydropower projects can provide significant grid-scale energy, though they may also have environmental and social impacts. While these conventional energy sources have played a crucial role, we must continue to explore and develop cleaner, more sustainable alternatives to meet our growing energy demands. Battery energy storage is crucial for hybrid energy systems, allowing excess renewable energy to be stored and used when needed. Pumped hydroelectric storage is a large-scale, efficient way to store energy by pumping water to an elevated reservoir, which can then be released to generate electricity. Thermal energy storage systems can store heat or cold energy and release it on demand, providing valuable flexibility for hybrid systems using solar thermal or geothermal sources. Flywheel energy storage systems use the rotational energy of a spinning mass to store and release energy, offering fast response times, high power output, and long lifespans for grid-scale applications and frequency regulation. Power inverters play a crucial role in hybrid energy systems, converting the direct current, DC, from renewable sources into alternating current, AC, that can be used by the grid or household appliances. Efficient and reliable transmission lines are essential for delivering the power generated by hybrid energy systems to where it's needed. This includes upgrading existing infrastructure and building new transmission corridors to integrate renewable sources. Substations and other power distribution equipment are necessary to step up or step down the voltage and safely deliver electricity from the hybrid system to end users. Careful system design ensures optimal efficiency and grid integration of the hybrid power system. The key considerations for designing an effective hybrid energy system include matching energy supply and demand, optimizing system efficiency, and integrating different energy sources. Carefully analyzing the energy needs and load profiles of the target application is crucial to ensure the hybrid system's energy generation and storage capacities meet the fluctuating demands. Optimizing the integration and operation of the various energy components, such as considering component compatibility, energy conversion losses, and intelligent control strategies, can maximize the overall efficiency of the hybrid system. Seamlessly integrating renewable energy sources like solar and wind with conventional fossil fuel-based generators is important to maintain a stable and reliable power supply through a smooth transition between energy sources and efficient load balancing. Real-time monitoring allows us to continuously track energy production and consumption across the system. Predictive analytics help us forecast future energy needs based on historical data and usage patterns. Dynamic load balancing enables us to adjust the mix of energy sources to meet changing demand, optimizing the use of renewables and conventional sources. By continuously monitoring, predicting, and balancing the energy supply and demand, we can maximize the efficiency and performance of our hybrid energy system. Effective energy optimization is key to a high-performing hybrid system. We need to maximize energy generation from all sources while minimizing losses. Load balancing is critical to match supply with real-time demand across the different sources. Integrating energy storage helps buffer intermittent renewable sources and optimize overall system performance. Taking a holistic approach to these three areas is essential for achieving optimal system efficiency. Careful analysis of the energy demands is key to determining the right mix of energy sources. Combining renewable sources like solar, wind, and hydropower with conventional sources like natural gas and diesel can create an efficient and complementary system. Energy storage technologies, such as batteries or thermal storage, help ensure a reliable and continuous supply of power, especially when renewable generation is fluctuating. Remote communities have seen transformative benefits from hybrid energy systems. These systems combine solar, wind, and diesel generators to provide reliable, sustainable power for isolated villages. Hybrid systems have been crucial for meeting the energy needs of remote off-grid communities. Large industrial facilities are adopting hybrid energy systems to reduce their carbon footprint and energy costs. By integrating renewable sources like solar and biomass with conventional generators, they can optimize energy production and storage. This allows industrial complexes to generate cleaner energy and save on utility expenses. Homeowners are increasingly turning to hybrid energy systems for their homes. These systems combine rooftop solar, battery storage, and backup generators. This enables homeowners to generate their own clean energy, reduce utility bills, and maintain power during outages. Remote communities often lack access to traditional electrical grids, making hybrid energy systems a great solution. These systems combine renewable sources like solar, wind, and hydropower with conventional generators fueled by diesel or natural gas. This diversity enhances the resilience of the power supply, ensuring continuous electricity even when renewable production fluctuates. Energy storage technologies like batteries and fuel cells further improve the reliability and flexibility of hybrid systems. The natural setting shown in the image highlights how these systems can be seamlessly integrated into remote, off-grid locations. Hybrid energy systems are a great solution for powering industrial facilities. They combine renewable sources like wind and solar with conventional generators. This provides reliable, cost-effective, and sustainable power, reduces reliance on the grid, lowers emissions, and ensures uninterrupted operations. Modular design allows easy scalability to meet evolving energy needs. Advanced control systems optimize energy usage, storage, and distribution. Innovative financing models and supportive policies are driving adoption in industry. This modern, clean architecture showcases the benefits of hybrid energy. Residential hybrid energy systems are becoming more common, combining renewable sources like solar with grid electricity or backup generators. These systems help reduce homeowners' reliance on the grid, lower their carbon footprint, and provide backup power during outages. The integration of renewable generation, energy storage, and smart controls allows for efficient energy management and cost savings over time. Homeowners can benefit from the reliability, sustainability, and cost-effectiveness of these hybrid residential energy solutions. Hybrid energy systems face a range of challenges and barriers that need to be addressed for wider adoption. Technical limitations, such as the intermittency of renewable sources and energy storage constraints, can impact the reliability and efficiency of these systems. Overcoming these hurdles is crucial. The high upfront costs associated with implementing hybrid energy systems can be a significant economic barrier, especially for smaller-scale applications. Innovative financing models and policy incentives are needed to address this. Outdated or inconsistent policies, as well as complex regulatory environments, can hinder the deployment of hybrid energy systems. Supportive policies, streamlined regulations, and clear guidelines are necessary to create a favorable environment for their development. Addressing these technical, economic, and policy/regulatory challenges will be key to driving wider adoption of hybrid energy systems. The slide discusses the technical limitations of hybrid energy systems, which are important considerations when implementing these systems. Grid compatibility is a challenge, as hybrid systems with fluctuating renewable sources may not fit well with existing electrical grids designed for more stable power generation. Energy storage capacity is limited, making it difficult to store enough energy to meet peak demand using current technologies like batteries. Geographical constraints mean that certain renewable sources like wind and solar may not be available in all locations, limiting the feasibility of hybrid systems. Hybrid systems can be complex, requiring advanced control systems and coordination between different energy sources, which increases technical challenges and maintenance requirements. Understanding and addressing these technical limitations is crucial for the successful deployment of hybrid energy systems. The high upfront costs of hybrid energy systems can be a significant barrier, as they require substantial investments in renewable technologies, storage, and power conversion equipment. It can be challenging to quantify the long-term savings and benefits of these systems, which creates uncertainty around the financial payback period and discourages potential adopters. Limited financing options, such as loans, grants, and incentives, can further hinder the widespread adoption of hybrid energy systems, especially for smaller-scale installations and low-income communities. These economic barriers need to be addressed through policies, incentives, and innovative financing solutions to make hybrid energy systems more accessible and appealing to a wider range of individuals and organizations. The deployment of hybrid energy systems often faces a complex web of regulations and policies that vary across jurisdictions, making the approval process challenging. Many existing energy regulations and incentive programs were designed for traditional, centralized power systems and are ill-suited for the distributed and dynamic nature of hybrid energy systems. Updating these frameworks is a slow and arduous process. Connecting hybrid energy systems to the existing grid infrastructure can be problematic, with utilities and regulators often resistant to changes that may disrupt traditional power distribution models. Establishing fair and transparent interconnection policies is crucial for widespread adoption. Hybrid energy systems, combining renewable sources like solar and wind, are overcoming technical challenges through ongoing R&D. Advancements are improving efficiency and reducing costs, making these systems more viable. Creative financing models like power purchase agreements and green bonds are helping address upfront capital costs. Supportive government policies, incentives, and regulations are further encouraging the adoption of hybrid energy systems. These technological, financial, and regulatory developments are all helping to drive the integration of hybrid energy into urban environments. Hybrid energy systems are becoming more advanced and efficient thanks to technological breakthroughs. Innovative battery technologies are improving energy density, charging speeds, and longevity, making hybrid systems more practical and cost-effective. Ongoing R&D in renewable energy like solar and wind is enhancing the performance, reliability, and affordability of these technologies for hybrid applications. Advancements in smart grid integration, including advanced control systems and energy management software, are enabling seamless integration of hybrid energy sources into the grid. These technological advancements are making hybrid energy systems a more viable and attractive option for powering our homes, businesses, and communities. Crowdfunding platforms allow communities to collectively fund hybrid energy projects, tapping into growing interest in renewable energy and sustainability. This democratizes access to capital and empowers local stakeholders. Green bonds are debt instruments that raise capital specifically for clean energy and environmental projects. These bonds provide a reliable source of funding for hybrid energy systems, attracting institutional investors seeking sustainable investment opportunities. Energy performance contracting allows businesses to finance hybrid energy upgrades by sharing the cost savings generated from improved energy efficiency. This aligns incentives and mitigates upfront costs, making hybrid systems more accessible. Collaborations between government entities and private companies can unlock funding and expertise for hybrid energy projects. These partnerships leverage public resources and private sector innovation to drive widespread adoption of sustainable technologies. Governments can offer incentives like tax credits, feed-in tariffs, and renewable portfolio standards to encourage investment in hybrid energy systems and offset upfront costs. Supportive regulations that enable microgrids and distributed energy generation can empower communities and businesses to generate and manage their own power, enhancing resilience. Collaborative policymaking, involving policymakers, industry experts, and community stakeholders, is key to developing regulations that address the unique needs of hybrid energy systems while aligning with broader sustainability goals. Hybrid energy systems are a promising solution to meet growing global demand for sustainable energy. These systems combine multiple renewable energy sources, like solar and wind, to provide reliable, clean power. The flexibility and complementary nature of hybrid systems make them well-suited to power homes, businesses, and communities as renewable technology continues to advance. Hybrid systems will become increasingly efficient and cost-effective. Transitioning to hybrid energy can help reduce reliance on fossil fuels and support a more sustainable, resilient energy future. The global hybrid energy systems market is projected to experience significant growth in the coming years, driven by advancements in renewable energy technologies, energy storage, and power conversion. The market is expected to grow at a CAGR of over 10% from 2023 to 2030, with the market size projected to increase from $XX billion in 2023 to $XX billion by 2030. Key emerging trends in the hybrid energy systems market include increased adoption of hybrid microgrids, integration of AI and IoT for system optimization, and growth in off-grid and remote area applications. Some of the most promising hybrid energy technologies include solar wind battery systems, hybrid renewable fossil fuel plants, and hydrogen-based hybrid systems. These advancements in hybrid energy technologies are driving the growth and adoption of hybrid energy systems globally. Hybrid energy systems are a rapidly growing field, with a surge of new patents and innovations driving progress. The adoption rate of these systems is projected to grow by 20% annually, as the global market is expected to reach $125 billion by 2030. These emerging technologies span advanced energy storage, intelligent grid management, and other cutting-edge solutions that will power the next generation of hybrid energy systems. The hybrid energy space is an exciting frontier, with researchers and companies pushing the boundaries of what's possible in renewable power. Hybrid energy systems are seeing a surge in global adoption as countries around the world recognize their benefits. North America has a high rate of hybrid energy adoption, driven by policy incentives, falling renewable costs, and grid modernization. Europe has a moderate to high adoption rate, motivated by climate change mitigation goals, renewable energy targets, and grid resilience. Asia-Pacific is experiencing rapidly growing hybrid energy adoption, expanding energy access, rural electrification, and sustainability initiatives. Latin America is an emerging market, with abundant renewable resources, reducing fossil fuel dependence and rural development driving adoption. As these trends continue, hybrid energy systems will play an increasingly prominent role in the global energy landscape, contributing to a more sustainable and resilient future. The future of energy is hybrid, a combination of renewable sources like wind and solar, paired with energy storage. Hybrid energy systems are becoming more advanced and widespread, signaling a promising path to sustainable, reliable, and cost-effective power. As technology continues to improve, the potential of hybrid energy to transform the global energy landscape is being realized. This slide sets up the key theme of the presentation: the bright future of hybrid energy systems. The vibrant, futuristic imagery helps convey the clean, innovative nature of these emerging energy solutions. Hybrid energy systems combine renewable sources like solar and wind with conventional power to provide reliable, cost-effective, and sustainable electricity. These systems reduce greenhouse gas emissions and improve energy security by diversifying the energy mix. Careful system design is crucial. Matching supply and demand, integrating different sources, and maximizing efficiency are key for success. While hybrid systems face technical, economic, and policy challenges, they can be advanced through innovations, financing models, and supportive regulations. Overcoming these barriers is possible, and hybrid energy offers a promising path to a more sustainable energy future. The future of energy is bright with hybrid energy systems. A combination of renewable and conventional sources, these integrated systems are revolutionizing how we power our lives, businesses, and communities. They offer greater energy efficiency, reliability, and environmental sustainability. Hybrid energy is a key part of the global shift towards more sustainable solutions. This slide sets the stage for the presentation by highlighting the promise and potential of hybrid energy.